Alright, this video is going to be on solving systems of equations, and since it's Algebra 2, we're going to actually be doing systems of equations where there's three equations. So here's an example. There's the first equation, there's the second equation, and there's the third one. But this is what we'd call a system of equations because there's multiple equations with multiple variables. And since there's three variables that you'd like to solve for, you need three equations to do it. And so this video will teach you how to solve this system by hand using the process of elimination. And so the first thing that you want to do when trying to solve this system is you want to take the overall approach and look at the system and decide which variable, whether it be x, y, or z, you want to decide which one has easier time of getting a common factor or a common multiple, excuse me. And so when I look at this, 4, 6, and 3 could common multiple could be 12. When I look at the y's, 3 and 6, a common multiple is 3, that's easy. And then 5, 3, and 4, see, now I got to think about it for a little while, and I don't know what I could really get there. Maybe third, no, I don't even know. See, so since I can't figure it out off the top of my head, I'm going to go with the middle one. And what I'm going to do is I'm going to try to cancel out the y's as I approach this using process of elimination. So I'm going to write the first two equations. First thing you're going to do is I'm going to take equation 1 and equation 2 and I'm going to set up a system and try and cancel out the y's. And then I'm going to take equation 2 and equation 3 and cancel out the y's there. And what it's going to do is it's going to allow me to have create a system of two variables, and it's kind of a process of elimination. So the first one equation is 4x plus 3y minus 5z equals -9, and then 6x plus 6y minus 3z equals 6, and then this one 6x plus 6y minus 3z equals 6, and then 3x minus 3y plus 4z equals 19. And so, like I said, up here I want to cancel out the y, so I'm going to cancel out the y. But you could cancel out the x's, but if you cancel out the x's, then you need to cancel out the x's in both situations. Or if you want to cancel out the z's, you would have to cancel out the z's. You just have to keep it the same. That's the key. All right. So as we look at this, elimination says that you have to have opposite coefficients. So I have a 6 here. So I would need a -6 with the 3y right here. And so I'm going to multiply this whole equation by -2. So everything gets multiplied by -2, so -8x minus 6y plus 10z equals 18. And then you just combine down. So it would be -2x, the y's would cancel out, plus 7z equals 24. And then in this one, as we look at it, I just need to multiply this one by 2. And so I'd have 6x minus 6y plus 8z equals 38. And so then I'm going to add down. And so I'll have 12x plus, let's see, -3 plus 8 is 5z. And that equals 6 plus 38, which is 44. And so this is kind of a longer process. So now once you've canceled out the y's, which we've done, you have two new equations. You've got these two guys right here. Notice they both have x's and z's. And so now you're going to set up a system of equations again. So -2x plus 7z equals 24. And 12x plus 5z equals 44. And you're going to do the process of elimination again in order to solve for these two variables, both x and z. So if you were to actually do this out, I think we would take the top equation and we would multiply it by 6, so that then you would have opposite coefficients with the x's, and when you add down, the x's would cancel out. So if you were to do this, you'd have negative 12x plus 42z equals 144. And then we're going to add down, so that'd be 0x, and then it would be 47z equals, and that would be 188. And if you divide, right, that's a z. If you divide 47 into both sides, z would equal 4. And so the whole point is to find what x, y, and z all equal. So now you've found what z equals, and you can plug 4 back in for z, say here, and you could solve for x. So I'm going to do that on the next page. So you have, I think we had negative 2x plus 7z as one of our equations equals 24. That was the one we multiplied by 6. So if I take that and I plug in z, we said z equals 4. So I'm taking that and I'm plugging it in. So negative 2x plus 7 times 4 equals 24. So then negative 2x plus 24, or excuse me, 28 equals 24. And then we'd subtract 28. So now we have negative 2x equals negative 4, and we have x equaling, when we divide by negative 2 on both sides, x equals 2. So now we have 2 of the 3 variables. So we have 2 and we have 4. And now we're going to plug it into any one of these 3 up here. So you can go with that one, or that one. And if you plug it into z and x into any one of those 3, you'll get your y value. So let's go ahead and just pick the first one. So we'll say 4, and instead of putting x, we'll put 2 because we solved it. X equals 2, right? And so plus 3y, which we don't know, minus 5 times 4 equals negative 9. Whoops, I ran out of room. That's a negative 9. And so you have 8 plus 3y minus 20 equals negative 9. And then you'd have 3y minus 12 equals negative 9. Add 12. So 3y equals 3. So we divide by 3, and y equals 1. So the way you're going to write your answer is as follows. You'll go and you'll write it as x, comma, y, comma, z. And so your answer will be 2, comma, 1, comma, 4. And that is how you do that one. If you were going to do a special situation, there are some special situations. So if you're going to do a special situation, there are 2 types of special situations that your teacher may ask. There's one where there's no solution, and then there's another where there's infinitely many solutions. And so how do you know which situation you have? Well, really, it kind of starts at the very beginning when you start eliminating things. And it could happen maybe further down the road in the process, but you do everything the same. You'll just be solving a problem, and then all of a sudden, everything will cancel out. And when everything cancels out, like all the variables cancel out, you're left with a statement. And if the statement is true, then you'd go with infinitely many solutions. And if the statement is false, you'll go with no solution. So let's just take a look at this guy. You've got x minus y minus z equals 5. And you've got 4x minus 4y minus 4z equals 15. So if I were to ask you, which variable do you want to cancel out when you're looking at the whole problem, you might say, well, let's go with z's. That seems pretty easy. And I would agree. Or maybe say y's, and you say, oh, that seems pretty easy too. And x's don't seem too bad either. But let's say we want to cancel out the z's. So if you're looking at this equation, you would want to multiply by, and hopefully you're saying out loud, negative 4 is what I'd like to multiply by. And so that would make it negative 4x plus 4y plus 4z equals negative 20. And we notice that the z's will cancel out when we add down, but also notice that the y's will cancel out and the x's will cancel out. And so now you're left with 0, because everything's gone, equals, and 15 plus negative 20 is negative 5. And then you ask yourself, is this true or false? Does 0 equal negative 5? And hopefully you would agree with me that we would say those are not equal, so this problem has no solution. And that's it. If it had said negative 5 equals negative 5, then you would have said infinitely many, or 0 equals 0 is probably the more likely one. If it said 0 equals 0, then you would go with infinitely many solutions. All right, that's it. Have a great day.